Alright, so we're in a new chapter, chapter 9, and in section 9.1, we are going to apply both the distance and midpoint formula. Both of these formulas are taken from coordinates on a xy coordinate plane, and the distance formula allows us to find the distance between 2 points, which is x1 and y1, and x2 and y2. And the formula that it's given is in the equation d equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And there's different ways that we can use the distance formulas to help us solve problems. Well, in our homework, to start off with, they want us to be able to determine what kind of a triangle we have with these specific points. They want us to know if it's going to be either an isosceles, equilateral, or scalene triangle. So a quick review from geometry, isosceles triangle is two sides of the triangle that are equal. Equilateral triangles have all three sides equal, I'm sorry. And scalene, none of the sides of the triangle are equal. Well, what we can do is we can determine the sides distances of each we can determine the dimensions of each of the sides by using the distance formula. So what you have to do is you have to then determine which one's your x1 and y1 and which one's your x2 and y2. So let's just say if I put d, imagine that's my x1 and this is my y1, and then this is my x2 and that's my y2. So to find DE, I need to take the square root of 2 minus negative 3 quantity squared plus 1 minus 3 quantity squared. So here 2 minus a negative 3, which gives me 5, which will then give me what? This will equal the square root of 25 plus 1 minus 3 is negative 2. Square that, it'll be what? 4. And this will equal the square root of 29. So the distance of DE is the square root of 29. So now if I go to EF, which is right here, I can go, and it doesn't matter which one you coin as x1 and y1 or x2 and y2, it's just as long as you're consistent throughout the entire process of the problem using the distance formula. So let's just say if I go 2 minus a negative 2, and then we have 1 minus a negative 1 here. This would give me 2 minus a negative 2, which would give me 4, and that would give me what, 16 plus, this is 1, that's what, 3, square that, it's 9. 16 plus 9 is 25, square root of 25 would just be 5. So we know for a fact that it's not an equilateral triangle because those two sides are not equal, but we'll have to determine whether it's an isosceles or scalene by what the distance of FD is. So just go, if I go negative 2 minus a negative 3 quantity squared plus, be what, negative 2 minus 3 quantity squared here, so that's going to equal square root of negative 2 minus a negative 3, that will give me what? Be what, 1? So 1 squared is 1 plus negative 2 minus 3 gives me a negative 5 squared, that's what, 25. So this ends up equaling the square root of 26. So since none of the values equal each other, I can say that this is a scaling triangle. All right. The next thing that we're going to do is find the distance formula. We can find the distance, find the midpoint for a line segment with endpoints x1, comma y1, and x2, comma y2, which can be found using the equation x1 plus x2 over 2, comma y1 plus y2 over 2, comma. So if I wanted to find the midpoint of A, I would say I'm going to go with negative 4 plus 8 divided by 2, comma 19 plus 6 divided by 2. And so negative 4 plus 8, which gives me 4. 4 divided by 2 is 2, comma, and 19 plus 6, which gives me 25. So it'll be what, 25 over 2? So the midpoint of that value would be 2 comma 25 over 2. And for B, I would go negative 2 plus negative 22 all over 2, comma 5 plus 5 all over 2. So negative 22 plus a negative 2 plus a negative 22 divided by 2. That would give me what? Negative 12. And then that's what 10. 10 divided by 2 is 5. All right. Last thing that they want us to do in our homework is be able to find the perpendicular bisector. And the perpendicular bisector is a line that divides another line segment into two equal parts and creates 4 right angles. Kind of something like this. So say we have a line here, and that means that we'd find the midpoint, which means that this distance here would be the same distance, and then we make another line that's perpendicular. So I'd have 4 right angles. That's where that comes from. And the procedure is if we are given 2 points, which will make a line, AB, first thing we have to do is we must find the midpoint of AB. Once we do that, we calculate the original slope of AB, and we do that by using the slope formula, where m equals y2 minus y1 over x2 minus x1. Remember that from probably from beginning algebra. Step 3 is we find the slope of the perpendicular line of AB, which means we just give it the negative reciprocal of that slope. Then once we use the slope formula to find the equation of the perpendicular bisector and put it into slope-intercept form. So we're going to use the point slope form first, and then try to solve it for y. So let me get some more room here. So here they want us to write an equation for a perpendicular bisector of lines AB. So this would be like point A, and that's point B. Again, this is point A, and that's point B. So let's do first things first. First thing is we need to find the midpoint. So let's find the midpoint. So let's go number 1. So to find the midpoint, I'm going to go use the midpoint formula. So it's 5 plus a negative 1 divided by 2, comma 4 plus 6 all divided by 2. So that would give me the midpoint value would be 2, comma 5. Okay. Next thing, step 2, is I need to find the slope of AB. And how I can do that is take m and go 6 minus 4 divided by it would be what? Negative 1 minus 5. And so here, here would be 2 over negative 6, which is a negative 1/3. And then third step would be to find the slope of the negative reciprocal. So the negative reciprocal here would be a positive 3. And then the last step is to use point slope form to find the equation. So, and what we're going to do is the point we're going to use is the midpoint, and then we're going to use the slope here to help us find that equation. So if I go y minus y1, well, y1 here is 5 from here, equals the slope, which is 3, times x minus x1, which would be 2 in this case because it comes from here. So now I put this in point slope form, so now the last thing I have to do is solve for y. So I'm going to go y minus 5 equals, I'm going to distribute these across, so it would be 3x minus 6, and now I'm going to add 5 to both sides, which then gives me y equals 3x minus 1. So my equation for my perpendicular bisector of AB is y equals 3x minus 1. So if I look at example B, first thing I got to do is I got to find the midpoint. And I can do that by doing 0 plus 8 divided by 2, comma, 4 plus 2, all divided by 2. And the midpoint for that would be 4, comma, so we'll put what, 3. And step 2 is I need to find the slope. So I'm going to go 2 minus 4 over 8 minus 0. And that will give me negative 2 over 8, which then equals a negative 1/4. Step 3 is I need to find the negative reciprocal for the slope. So my new slope will be a positive 4. And then the last thing is I'm going to use my new midpoint and my new slope to help me get it into point slope form to help me find the equation. So I got y minus 3 equals, and the slope would be 4, and then I got x minus 4. So I'm going to distribute the 4, so I got y minus 3 equals 4x minus 16. I'm going to add 3 to both sides, and I will get y equals 4x minus 13. So my line for my perpendicular bisector for these points is y equals 4x minus 13. And that is being able to apply the distance and midpoint formulas. Hope this helps. Until next time.